ACS gas training, electrical equipment and testing. My name's Hart, and in today's video I've got a super trainer today, and we're going to show you the electrical testing equipment, but also how to test some of the components inside a boiler. So testing gas valve, testing sensors inside the gas valve, also doing your electrical checks. This trainer today is trained me for many years. I've been on lots and lots of his training courses, so I'm very excited to pass you over to Roy.
Hi guys, my name's Roy Fugler from Viva Training Academy, and today I'd like to go through electrical test equipment that you guys as gas safe registered engineers may be using. Some of it is because of legislation, some of it is to help with fault finding. So first off, we'll start with a really simple thing, a volt stick. There's various versions of these. They're very simple and handy tools to use, mainly used to prove that there's no power there. So for instance, if you're going to work on a boiler, you don't want to get an electric shock off the case, you'd use that to prove that the case has got no power at that case, so it's not become live. The next bit of equipment we're going to use is a socket tester. There's two versions of a socket tester here. There are all sorts of different manufacturers who make socket testers. This one is simply plugging in and you've got three lights, and that proves that that socket, the polarity is correct. This one here, we've got connection so we can put a multimeter in or a voltage indicating device. Again, we can prove that that's working, so we could use that to prove, once we know that that socket is wired correctly, we could use this one to prove the device that we're going to use is working on what's called a known supply. Because a lot of the equipment we use, we need to prove it before we use it. So it's prove, use, and then prove again. So those two. The next couple of bits of equipment, multimeters. Most of you guys, if you're going to be doing fault finding, will have a multimeter. It's the most important tool in my toolkit, to be honest, apart from a screwdriver. Obviously I need a screwdriver to take the case off the boiler. This one, it's a multimeter made by Martindale. You've also got an amp clamp, and it does non-voltage contact indication, which is the same as your volt stick. So that's a multimeter. The other one that I've got is a Fluke 116. This one's known as the heating engineer's multimeter, because again, this one does temperature. I personally don't use it for temperature. I prefer to use my flue gas analyzer on temperature. So the next bit of equipment we're going to look at is a voltage indicating device. Again, this is a Martindale version. This is there when we do safe isolation. We use this to prove that the voltage is present or not present. There's no batteries in it, it works purely on being in contact with the voltage. So that's a voltage indicating device. Another voltage indicating device is this one. This is a Fluke. This one's got a few more features. There's a little digital display as well as some lights that come up. So that's another voltage indicating device. It talks about proving. I've already mentioned we could prove on a live supply, but we could also use a proving unit. This is a proving unit. It's full of batteries, and when we put our probes in there, it will prove our device is working. We can use it to prove voltage indicating devices. We can use it to prove multimeters. So that's a proving unit. The next bit of equipment is a loop impedance tester. It's become important now that we check that the earth doesn't just go to the fuse spur, it goes back to the consumer unit. In the past, as gas engineers, we've been proving earth continuity, normally from either the fuse spur or the socket that the boiler is plugged into. We now, because of legislation changes, we need to prove it's going further back, so loop impedance testers. This is a socket and C version, and that's a Martindale version. So what we'll go on to now is a little bit more in-depth look at each piece of equipment and how we would test it. Right, so we've been through the various bits of test equipment. I'm now going to show you putting them into use. So first off, we've got the volt stick. So the idea is this boiler, as you can see, is up and running. We've got the light on and the displays on. So all I want to do is prove that that case hasn't become live because it hasn't got a fault on. It could become live but not trip the electricity because of another fault. So the first thing I'm going to do is just turn my little volt stick on and then turn on the socket, and just by popping that in, as you can see it goes nice and red. That proves my voltage indicator, my volt stick is working. So now I just lightly run it down the case. As you can see the little red light's flashing, but it's not beeping and it's not on continuous. So that proves that that case is safe for me to touch. So I can now touch the case. So I've noticed that the boiler's fitted to a fuse spur. So my main point of isolation would be that fuse spur. So I would turn that off, pop the fuse out, check the fuse rating. But the light's gone off, but the display is still on. That would indicate that I've got 2 points of isolation. It's unlikely that you'd find this out in the field, but not impossible. It's something I in my career have come across. So we've got a socket up there. What we need to identify is that socket feeding the power into this boiler. If we trace the wire down, it looks like it's coming in there. So just by turning that socket off and unplugging it, does that kill the display? Yes, it does. So what I need to establish now is, has that polarity, or is that polarity correct on that socket? That's where my socket tester comes in. So I can plug that in, turn it on, and as we can see, the 3 lights have illuminated, which is telling me I've got correct polarity at that point. So the next stage now is removing the case on the boiler and tracing the wires through. So as you can see, I've removed the case off the boiler, I've removed the fuse, checking that it's a 3 amp. Now in a real life scenario, when we're doing safe isolation, we will be isolating that fuse spur. There's various ways to make sure that that's isolated. One of them is this little cover, where you would slacken off the 2 retaining screws on the fuse spur, fasten that over, pop it on and put a padlock on. So there's a larger padlock. You could, if the type of fuse spur allows, put a little padlock through. I prefer these with the little numbers on because I can't lose the key. However, there are ones with keys on. The very simplest way is to use a cable tie. All you're doing is making sure that that's locked off and nobody can turn it back on if you move away from that appliance. So the next thing we're going to look at is proving that that boiler is isolated. So the first thing I'm going to do is use my proving unit and my voltage indicating device. That's my voltage indicating device. I've got my proving unit, and what I need to do is to prove my voltage indicating device on my proving unit. So I basically plug that in and I'm looking to make sure all the lights come on. So I know that that's proved. I'm going to drop the front on the boiler. I'm going to access the terminal blocks, which on this particular boiler are 2 little clips. Lift the cover up, and then I'm going to check across live neutral, live earth, neutral earth. If I've got it isolated and there's no power going to it, I shouldn't get any lights coming on. If I do, I may have isolated it at the wrong place. As we notice, we've got 2 points of isolation. Both have been disconnected. So we're going on to live and earth, no lights, live and neutral, no lights, and neutral and earth, no lights. So we can safely say that this has been isolated. What I need to do now is to prove my unit again. It's prove, check, prove. So again, with my proving unit, into there, pushing them both down, and the lights have come on. So we've proved that the main incoming is dead. Obviously, this being a system boiler, and we have 2 points of isolation. What I've established is that the 3-pin plug, that is feeding the live, neutral and earth to the boiler. The switch live for the heating circuit and the hot water circuit is actually coming from the fuse spur. So what we'd do in that scenario, we'd also prove that those are dead by using the same equipment. What we're going to move on to is looking at loop impedance testing. Why we would do that. We'll also move on to looking at multimeters and where they become useful. So I'm just going to pop the boiler back up and running, and we'll come back to that shortly. So we've now got the boiler plugged in on both the fuse spur and the socket. So we're now going to use the loop impedance tester. The loop impedance tester is proving that the earth not only just goes back to the socket, but goes back to the power station. The main reason we need that earth connection in there is in case of a failure, it fails to safety. Making sure we, as the gas engineer working on that appliance, we don't get an electric shock. If we do something stupid and a shock occurs, make sure it's as painless as possible by very quickly going and failing to earth. Because we've obviously got a 3-pin plug, these loop impedance testers come with both plug testers and probes. So we're going to plug it in at the side of where that 3-pin plug is, and we're just going to plug that in, turn it on. So the first check that it's doing on this socket and C version is a polarity check, so we know that the polarity to that socket is correct, live, neutral and earth. There's a little test button that we push in for loop impedance, so we push that, it then goes through a self check, it proves it's again wired correctly, and we've got a low reading on loop impedance, less than 1 ohm. The lower the ohms rating, the faster that electricity can pass through. So we know that the 3-pin plug is plugged into a good earth. Down at the boiler, we then change over onto some probes. So again, we just plug this in. We have an earth clamp, which we put onto just a bare metal part, or an earth tag if there is one on the particular boiler. So we have that there. We'll then go on to live and neutral. Now this is polarity sensitive because it's going to check the polarity. What that means is if we put it onto the brown connection onto a neutral and the blue on the live connection, it'll come up that the boiler's got reverse polarity, that the live and neutral are the wrong way around. So it's important that when we put these two connections on, we actually go live onto live, neutral onto neutral. It's now checked the polarity, which is good, and we push the little loop impedance test, and again we've got less than 1 ohm, so we know we've got a really good earth connection, so it's very, very safe for us to work on that appliance. Next, we're going to move on to multimeters. So the next thing we're going to look at, multimeters. Multimeter, very, very useful piece of equipment. In the past, we've used this equipment for safe isolation. However, it's no longer appropriate. We've got to use the equipment that we've just shown, loop impedance tester, voltage indicating device. The reason being is in the name, it's a multimeter. So unless I've been shown how to use it, and I'm trained to use it, I may put it on the wrong scale. So if I'm looking for voltage and put it on, let's say for instance, ohms, which is resistance checking, I'm not going to get the correct reading. So these come into their own for fault finding and things like that. There are some basic electrical safety checks that we can do with this. One used to be earth continuity. I don't tend to bother now because I'm using my loop impedance tester to prove my earth goes all the way back. But in the past we've used it to prove that it's earthed to either the fuse spur or the socket. So when we're using a multimeter, we need probes. Now, there's an official document, and it's the health and safety, it's called GS38. It talks about appropriate equipment. Now, one of the things it talks about are probes. So I'm just going to stick my multimeter up there. I quite like the idea of having the magnet. I don't need to hold it. So these are a set of probes I've got. These aren't very appropriate, but they're useful, and I'll explain. The probes on these have got too much tip showing. There's a chance if I touch that and I'm working on voltage, I could get a shock off it. The finger guards aren't very big. Again, with big fingers, you could slip over and do onto there when they're live. So they're not really appropriate, but these are the probes I use because I'm confident using my multimeter. A more appropriate set of probes, and under GS38 this is what we should be using. As you can see, there's only a small amount of tip showing on there, and you've got big finger guards. The other thing is these are fused, so again it's like wearing a belt, braces and a piece of string to hold your pants up. Very, very safe, very usable. The downside is when you're trying to get in on small components on boilers, it's very difficult to get in there. And the majority of testing I tend to do on boilers is resistance testing, so there's no voltage, it's what's termed dead testing. So I'm going to pop my probes into this multimeter. Now the good thing about multimeters, I've been asked over the years, what's the best multimeter to get? I would say the simplest multimeter that you can find. You can buy all sorts of multimeters, ones with more holes in than this has got. This has literally got a common and one connection. You'll come across some with 2 connections, 3 connections, sometimes 4 connections. Very, very useful equipment. The downside is when you're new to using a multimeter, less is more. The more you have on there, the more likely you are to make mistakes. In the past I've come across guys coming on training courses with multimeters costing in excess of £300. It's just not worth spending that. You're not electronics engineers, we're heating engineers, gas engineers that are using multimeters to help us fault find. The good thing about only having 2 holes, I can't put the probes in the wrong ones. The red goes into red, the black goes into black. Now if I'm doing dead testing, I'm on the ohm scale. The ohm scale is a symbol, it looks like a horseshoe, so that's very, very simple. It's resistance. The first thing I'm going to do is check any resistance in my leads, because it might be that I need to take that away from any readings I get if it's a particularly low reading. So I just put the 2 probes together, look at my multimeter, and it's coming up at 0.10, 0.2 ohms, so it's a very low reading. So I need to remove that or take that away from any readings that I get. So next we're going to have a look at testing 1 or 2 components. So for those that know me, I've spent the last 20 years working for Baxi. I'm now stood in front of a Worcester, but it's a boiler, and hopefully I'm experienced. I've got a multimeter. I'm just going to show you how to check a couple of components, but the first thing is making sure you've got the manufacturer's instructions. Because if I want to check something like the flow thermistor, I need to establish where it's located. I need to establish where it's connected onto. So I've got a set of instructions. That there, number 11, is telling me that's my flow temperature sensor or NTC sensor. So that's where it is. If I trace the wires through, they're coming down here and going onto a plug, and they're numbered 1 to 17 on that plug, and it's the 2 red wires on there. So the first thing I'm going to look at, I'm just going to pop the power on and just establish what temperature, because that's what that's doing, that's what that sensor does. It sends a signal back to the circuit board and identifies how warm the temperature is. So I know that it's at 54 degrees. So if I turn the power off, disconnect it and remove it all, then look into the instructions further, I've got a temperature chart there which gives me resistance readings and temperatures. So it's saying there that the resistance at 54 degrees should be around about 3,856 ohms, because that's at 55. So it's going to be somewhere around about that. NTC means as that temperature goes up, that resistance goes down. So my figure's going to be somewhere in that region of 3,200. Now, sometimes one of the mistakes that can be made is leaving the plug plugged into the PCB. If we do that, we could get a backfeed off that board. The manufacturers will instruct you whether you test it with it plugged in or with it plugged out. There's no power to the boiler, it's dead testing. So I'm going to go on to the 2 red connections and see what figure I get. The figure I'm getting is round about 3,000 ohms. So that's showing that it's out. It's showing it's a higher temperature. So this may be one that I need to remove the plug. So I remove the plug, go into the 2 red connections, the figure there is saying 4,100. So 4,100 is somewhere between 55 and 50, so that's giving me the correct reading. So that's how you would check a thermistor. We're going to move on to checking the gas valve. In the instructions, the manufacturers tell you there between connections on one, so we've got the top connection and the second to bottom connection, we should have a resistance of 6,100, and on the bottom two connections we should have a resistance of around about 900. You're checking the two main solenoids. That gas valve's got two solenoids on there. So again, what we need to do is remove the plug. I've already removed the screw for ease. So I'm going to go on to the top connection and the second to bottom. And I've got a figure of 5,900, and I'm looking for a figure of 6,001. That's within the tolerance that the manufacturers would allow. And then the bottom two connections where I'm looking for around about 900, I've got 910. So again, that's showing that that gas valve is in the correct tolerance. So that's simply how we'd use a multimeter. It's important you've got it on the right scale. More important is having the manufacturer's instructions to give you the correct figures. Different manufacturers might use the same gas valve, but they may have different figures based on the solenoid that they're doing. So that's just a little bit of a hint and a tip on gas valves and thermistors using a multimeter. In the future we're going to do more in-depth testing videos, so come back to us when we do those.
Thank you very much for that, Roy, and thank you to Viva Training Academy for helping and supporting this channel and doing these videos for us. Always remember, if you're going to work on a boiler, it must be gas safe registered or competent to do so. Always make sure you're going to check the installation instructions and make sure that you're doing all the tests to the current regulations at the time. Things change and different manufacturers ask for different testing, etc. So always make sure you conform to the current regulations at the time. Thanks for watching.